Hi, welcome to Learning Monkey. I am Raghu here. In this class, we discuss about the stack implementation in Python language. As we already discussed, this playlist belongs to the coding improvement and placement, how to crack the placement exams. As we already discussed in the beginning, in order to crack the placement exams, or if you want to improve your coding skills, data structures is compulsory. Without data structures, you don't get the skills of you don't get the coding skills. You cannot easily crack the placement exams because 50% of the placement bits consist of data structures. Okay, so it is compulsory to understand data structures. Our assumption is you already know what data structures are. We will give you an intuition about how to implement our data structures in Python, because this intuition will help you a lot in solving the placement questions which we discuss in our coming classes. In this class, we will give an intuition about stack. With this intuition, you can continue your implementations of queue, priority queue, all those things, all those data structures. In our next class, we give you an intuition about a linked list. With that intuition, you can continue implementation of double linked list, binary search tree implementation, insertion and deletion operations in binary search tree. You can do it on your own. This intuition is enough. If you don't know what data structures is, please visit our data structures playlist, learn the concepts, then try to implement those concepts in Python. In data structures playlist, we already implemented the concepts in C language. You do it on your own on Python. That is the best practice. Do it on your own. It's very, very important. Understanding data structures, implementation of data structures is very important in improving your coding skills. Okay, coming to the today's class, we will refresh the concept of stack. We will just refresh the concept. We won't give you the deeper understanding of the stack. We are in an assumption that you already know what stack is. Okay, so this is what stack is. Stack means last in first out element should be inserted, and one by one the element should be inserted. Last inserted element should be displayed first. So on the stack we are having three operations: push, pop and display. Push means insert the element, you should be inserted the element. Pop means you have to pop the element that is last inserted, last in first out. So that is what stack data structure is. In order to do that, what we are doing here is we are taking a variable stack top. Each time this stack top variable will point to the topmost element, so that when you apply the pop operation, this topmost element should be taken out. So this is what about the basics of stack data structure. Now coming to the implementation part, see. So we are implementing using NumPy arrays. Many of them will implement stack data structures using list and other concepts. Why we are choosing this NumPy? NumPy means implementation of pure stack. Stack will take a homogeneous elements, means stack of integers, stack of characters. In order to provide that homogeneous, NumPy arrays are homogeneous elements. They will accept only integers, or they can accept only strings, but lists are not like that. In order to provide that pure implementation of stack, we are using NumPy arrays. Okay, we have defined a class stack data structure, and in that we are defining a constructor in it, and it is taking a variable called size. Means what's the meaning of this? Whenever you create an object for this class, you have to pass the size variable. If you pass the size value as 5, it will create an array of size 5. So stack of size 5 is provided. Stack of size 5 is provided. That is what, see here, self.stack variable, we are taking a variable called stack is equal to np.nd array of what is this NumPy nd array. All these basics are discussed in our Python playlist. We are not going into that. So size means it is creating an array of size 5 with d type is equal to I, means it will accept only integer values. So that is why we are using NumPy arrays, and we are taking a stack top variable. Stack top is equal to, initially it is going to be -1. So what's the use of defining it in class? Class stack data structure. So if you create an object, object is going to create an stack of size 5. On that stack you can apply all these methods: push method, pop method, display method. So in the placement questions, they are going to say that already stack data structure is implemented with these operations: push operation, pop operation, and display operation. Use this data structure, stack data structure variable. They are going to provide you the object of that stack data structure. Means you have to understand that we can use the methods that are present on the data structure and solve the questions. That is why, to get the intuition, we are providing an example of implementation of stack. This is enough to understand the remaining data structures, queue data structure, and all those things. You try to implement it. So what's this push function? So let me refresh the concept of push function. What's the push function? If stack top is equal to length of the stack, stack is full. Otherwise, increment the stack top variable, it is going to be -1 to +1. -1 +1 means 0th position. At that position, insert the element. Push function is taking the element. Okay, so element will be inserted. Pop function, what's the logic for pop function is, so self dot stack top is equal to -1, stack is empty, there is nothing to display, else print element popped is stack of self dot stack top, whatever the element that is present on the stack top, display it and reduce the stack top variable to -1. So display function means display the elements from stack top to the 0th position. For I in range of self dot stack top to -1 means up to 0th position in reverse order. In order to display that, we are using this variable. All these things are basics. So print self dot stack of I. So come here, we are creating an object of stack data structure of 5. Means it is creating a stack data structure of size 5. You can create any number of objects, because stack is class is already provided. We are creating object 1, ob1. On that we are applying ob1 dot push off. So this is what they are going to say in the placement tests. Already stack data structure is available with these operations: push, pop, and display operations. You can directly use that object. They are going to give you the object name. With that object name, you can directly call the functions. That intuition you should have, otherwise it's difficult to solve the placement questions on data structures. So that's why we are explaining it. ob1 dot push of 10, ob1 dot push of 20 means we are pushing 10 and 20 element. When you display it, it is going to display 20 and 10. Next, ob1 dot pop means it is going to pop the element 20 from the top of the stack. ob1 dot display means, again displaying means it is displaying the element 10. So the output is element inserted, elements in the stack are display function. This is 20 and 10. Element popped is 20. Elements in the stack after popping the element, that is 10. This is how we will implement the stack. And in our next class we are going to discuss, we will give you we will give you an intuition about how to implement linked list in Python. So that with that intuition, you try to solve the remaining binary search tree, all those things on your own. That is the best practice to improve your coding skills. These are very, very important to improve your coding skills. Hope you understand the concept. If you have any questions regarding the concept, please post your questions in the comment section below. Thanks for watching. If you haven't subscribed to our channel, please subscribe to our channel and press bell icon for the latest updates. Thank you.